Hello everyone, welcome back. We're going to start part 2 of our Clue 4 Fieldwork in Japan. In the last clue, in part 1, we took a look at different types of eruptions, effusive or quiet versus an explosive eruption. And we talked about places where you're more likely to see those types of eruptions. We used Hawaii and Iceland and Japan as examples. So in part 2, we're going to be taking a look at the different types of volcanoes and how they're classified. So first of all, in your notebook, you want to add the definitions of active, dormant, and extinct to your vocabulary. Active being a volcano that is erupting, has erupted, or will erupt soon. Dormant being volcanoes that do contain magma, haven't erupted recently, but could. And extinct being volcanoes that have no more magma in them and have not erupted in a very long time, probably never will again. Go ahead and pause to add those to your vocabulary list. The first type of volcano we're going to take a look at is called a shield volcano, and they call it a shield because of its shape. It's this very broad, flat-shaped volcano. Kind of think of Captain America's shield if it were placed on a table. Side view of it. So very broad, very flat. Alright, so the shield volcano, it's a gently sloping volcano, so the lava can flow very far from it. It tends to have very low viscosity magma, so you get very quiet, effusive eruptions. Go ahead and add the definition for shield volcano to your vocabulary now. So a shield volcano usually is non-catastrophic, which means it doesn't have those explosive eruptions that we see. It's much more effusive because it has low viscosity lava, low silica content, and the temperature tends to be a lot higher. Examples would include Mauna Loa in Hawaii and Bardarbunga in Iceland, the video that we saw in the last part. Right now I'd like you to take out your big map and make sure you add those two volcanoes. Mark them with a V on your big map. 19 north, 155 west for Mauna Loa, 65 north, 17 west for Bardarbunga, Iceland. Go ahead and pause to do that now. So shield volcanoes like the ones in Iceland or in Africa's Great Rift Valley, they tend to occur at divergent boundaries or at hot spots. Right, so divergent boundaries and hot spots tend to be areas where magma can easily flow from the depths of the mantle up, so it tends to be hotter and it tends to flow pretty easily. And that's why we tend to see more shield volcanoes there. So in the table that I had you make in part 1, I'd like you to update shield volcanoes. And the eruption style is effusive or quiet. The gas content is pretty low, as well as the silica content. It's about 50%. And then the viscosity is low, the temperature is high, and they tend to occur at divergent or hot spots. Go ahead and update, pause to do that now. The second type we're going to look at are called composite, or sometimes they're called stratovolcanoes. You'll hear them referred to either way. And they tend to look a lot more like how we think of a volcano. They're a little bit taller, more cone-shaped. And they tend to be, like I said, steeper sloped. They actually alternate effusive and explosive eruptions. So they may kind of drizzle out lava one day, and then the next eruption might end up being an explosive one. And that's why they kind of end up forming these layers of lava and ash. You get a lava flow that forms a layer of lava when it cools, and then you get an explosive eruption, and then all the ash settles down and you get a layer of ash. So they tend to kind of alternate, and you end up with these layers. Mount St. Helens in the Cascades would be an example of this type of volcano. Go ahead and add the definition for composite stratovolcano to your notebook. Pause to do that. So composite volcanoes, they tend to have medium silica, medium viscosity, and medium temperature, which is what contributes to the kind of alternating effusive and explosive eruptions that they have. Because the silica and viscosity are kind of in between, they can get both types of eruption. And Japan is a perfect example of a place where that happens, as are the Cascades. These are both places where subduction are occurring. So stratovolcanoes tend to occur at convergent boundaries, where there's a plate subducting underneath another plate, and they tend to occur a lot around the Ring of Fire because of that. Also the Mediterranean belt, where we saw Mount Etna just recently erupted. You'll also get composite volcanoes there. The Philippines, another island arc, and then the Aleutians in Alaska. So explosive eruptions are due to higher pressure that builds because of the medium viscosity of the magma. It'll flow for a little while, but it'll eventually plug up the vent, and then you'll get the explosion. Some examples: Vesuvius and Mount Fuji, I would like you to add to your big map. So 41 north, 15 east, 35 north, 139 east. Pause to add those now with a V. You're going to go ahead and update your table for stratocomposite volcanoes. They have mixed eruptions, both effusive and explosive. They have medium gas content, medium silica, medium viscosity, and medium temperature, and they occur most at convergent boundaries where subduction is occurring. The final volcano we're going to look at is called a cinder cone volcano. They tend to only erupt once. They're named for their cone shape, and they usually have shorter eruptions. And they're formed by thick lava that's thrown high up in the air, and it falls as chunks or cinders at the edge of the volcano. So a lot of the times you'll see cinder cones forming just at the bottom of other volcanoes. An example is Paricutin in Mexico. This is a volcano that sprung up almost overnight in some poor farmer's field, and it grew to great heights. So I'd like you to mark that one on your map. It's 19 north, 102 west. Go ahead and pause to do that. Also add cinder cone to your vocabulary. Add the definition in the description. Pause to do that now. So cinder cone volcanoes have the highest silica, highest viscosity, and lowest temperatures of the three types of volcano. All of this leads to very explosive eruptions. Like I said, they tend to be the most explosive. They're created from oftentimes the pyroclastic, that's the explosive eruption of other volcanoes. They form at kind of the base of the volcano. And they often erupt just once and then they're done. So like I said, they form at the ends of other volcanoes. Go ahead and update your table. Cinder cones are explosive. They have high gas, high silica, high viscosity, and high temperature, and they occur at the sides of other volcanoes. Pause the video to update your table now. So just to recap, we have three different types of volcanoes: shield, cinder cone, and composite or strato. As the viscosity of magma increases, the more likely the volcanic vent will plug and pressure will build, and you'll get an explosive eruption. Explosive eruptions lead to steeper sloped volcanoes. All right, so just want to make sure that we kind of can have an answer to each of these questions. How does the amount of silica affect the viscosity of magma? We already said more silica, more viscosity, right? How does the viscosity of magma affect the shape of the volcano? So more viscosity means the magma doesn't flow as far. It builds up at the top, and you get more explosive eruptions, so it's going to lead to a steeper slope. How does the type of boundary affect the type of volcano? So we talked about how in Japan, the reason they have more explosive eruptions than in places like Hawaii or Iceland is because of the subduction that's happening there. So in places where subduction occurs, you end up with more silica in the magma. You end up with slightly cooler magma, which means more viscous magma. So the type of boundary really does matter when you're trying to think of what type of volcano will form there. And I will leave you with some fun facts about volcanoes. Thank you guys. This has been great. I will see you tomorrow. Have a great night.